Hey, welcome to everybody in my channel. Today we have a new interesting permutation proof for you. So n permutation R is equal to n minus 1 permutation R plus R n minus 1 permutation R minus 1. So that is, we want to prove this result, right? Taking left hand side is n permutation R. We are expanding n factorial n minus R factorial. Further solution is not possible in here, so we can give equation number first. Now taking equation number taking right hand sides, and here right hand side is n minus 1 permutation of R plus R into n minus 1 permutation of R minus 1. So now we are expanding this term. We get in here n minus 1 factorial and n minus 1 minus 1 minus R factorial. This will be factorial plus and R. So and here we get n minus 1 factorial divided by n minus 1 and minus R minus 1 factorial. Whole bracket close. Now further simplification we are doing in here, n minus 1 factorial and n minus 1 factorial, but we are trying to arrange this term in here n minus 1 factorial, n minus 1 factorial, n minus R minus 1 factorial plus R and n minus 1 factorial divided by, expand this term, and this one is n minus 1 minus R and plus 1 factorial. Close the bracket. So minus 1 and plus 1 are cancelled to each other. Now we are proceeding to the next steps, and here n minus 1 we are expanding this term also, n minus 1 factorial divided by n minus R minus 1 factorial plus R n minus 1 factorial, and expanding this term n minus R, consider is n mind, that is consider is n minus R and n minus R minus 1 factorial close. According to here we are expanding to these terms. Here this term and this term is common, and also in the denominator this term is common. So taking common, n minus 1 factorial and n minus R minus 1 factorial is common from both, and here is 1 is remaining, and here R and n minus R is remaining. Now we are taking off LCM of this. We can also write n minus 1 factorial divided by n minus R minus 1 factorial, and this term is, we are taking n minus R is the LCM. We are multiply this term and by 1, so we get n minus R and plus R. So the result, both of this are cancel. N is here we bring up to the first term n minus 1 factorial, and n minus R we bring to the first term n minus R into n minus R minus 1 factorial. Now this term we can write n factorial, and this term we can write n minus R factorial. We get in here equation number second. If we are comparing equation number first and second, both results are same. So that is the required proof of this both. Thank you very much for watching. Please subscribe my channel and share this video more and more.